Hi, I'm Jeff Brubaker, Marketing Manager at G2 Building Products, and I'm thrilled to be hosting this online call with experts on MST structural fiberglass rebar, structural engineering, and, of course, insulated concrete forms. We're calling this panel discussion Your Top 10 MST Bar Questions Answered. Now, to be fair, we actually have a couple bonus questions, so it's more like the top 12. Anyway, why are we doing this? Well, G2 Building Products has partnered with MST Rebar Inc. to provide MST bar fiberglass rebar to the ICF industry across United States and Canada. As the construction industry is changing and fiberglass rebar is quickly becoming the preferred method of reinforcement, it's important to clarify what exactly MST bar is and how it compares to other fiberglass bar in the market, but also how does MST bar compare to the conventional steel rebar, and why are contractors quickly switching over? Before I go further, I should mention this Q&A session wouldn't have been possible without my colleague, Matt Parr, also known as NYA Millennial on YouTube. Now, I'm going to just open this up and we can see everybody. Matt, thanks for not only being part of this discussion, but allowing us to share this forum on your YouTube channel, NYA Millennial.
No problem. I appreciate all the support that's been given. It's been greatly appreciated.
Well, as you know, Matt, the questions our panel is going to address today come from comments made on your previous videos about MST bar.
That's correct.
To quickly recap, you had the pleasure of traveling up to Toronto for a tour of the MST bar manufacturing facility, and you shared that video on your channel.
That's correct.
Then after that, when it came time to install the MST at your castle renovation in Southern Indiana, Marty from G2 dropped in and offered a little guidance on the job.
Absolutely. And we made sure it was interesting, and it was the second floor instead of the first floor. So there was a little bit of install prior to the expert showing up. But once he showed up, I actually learned a few things, which is great. And I think both sessions went exceptionally well. And I learned an entire amount on this product. It's a crazy, crazy amount that I learned.
And so now today, we've got something even extra special. We've compiled a team of experts to answer the questions that your YouTube viewers have asked and want to know about. Looking at this crew, I think it would be hard pressed to find anybody else that has more knowledge or experience in fiberglass rebar and ICF construction than the guests that we have on the call today. So let's meet them and we'll get started. First, I want to introduce Borna Haji Marala, and Borna is the founder and CEO of MST Rebar Inc. Borna, you are the creator of MST bar, and that includes the formula that makes it a grade 3 structural fiberglass rebar. Thanks for joining us, Borna.
My pleasure. Thank you so much, Jeff, for having me. And thank you, Matt, for having us and organizing all this.
No problem.
Great. And Borna is joining us from Toronto, Canada today. Right. Next, we have Alicia Aikenberry. And Alicia is a professional structural engineer who is based in Idaho. And Alicia has 20 years of experience in structural design engineering, project management, field review, and construction administration. Alicia, thanks for being on this call.
Thanks. Yeah, my background with designing for non-metallic reinforcement really kind of brought me into the world, and I loved it, never left.
That's great. Perfect. And Marty, as some of you may have met before as well, Marty is the MST bar technical advisor here at G2 Building Products. And Marty has been involved in the ICF industry for over 30 years. Marty is one of the few go-to experts for installer training and solving problems that others just can't seem to figure out when it comes to ICF. So Marty, thanks again for being on this call. as well.
Glad to be here and a great team to work with. Thanks, Jeff.
You bet. And of course, Mr. NYA Millennial Matt Parr.
We're here.
Okay, so let's jump in. First question that we want to ask here is this one is going to be directed towards Borna. And Borna, this is a question from NYA Millennials channel, but what is MST bar made with? And more in context, from a materials used point of view, how can we be assured of its structural integrity?
Thanks, Jeff. That's a really good question. MST bar is manufactured by glass fiber. Glass fiber are a tiny fibers that are about 1/10, 1/3, 1/4 of your hair diameters, and they are getting impregnated into a very high performance polymer. This is, in our case, is a vinyl ester resin. Vinyl ester resin is a very, very high resistant to corrosion, very strong, high temperature resistant. And those glass fibers are in the form of strands are causing the bar to have that tensile strength, and obviously shear performances and all the other performances that we see. So the material is manufactured by glass and fibers put together to create a composite rebar.
Great. Any other comments from like Alicia? I know you've had a lot of experience with this. You said non-metallic rebar is really how you got involved in this. How have you been able to use that in your drawings and in your designs?
Well, my master's thesis was on composites, so I actually did a lot of hands-on building of composites using glass and carbon and all that type of stuff. In grad school we made our own skateboards, so understanding the resin, how the resin's so important with the glass fiber and cure. And I think a lot of it is finding the best product that does the best of all of it. So it's like a recipe. So the best recipe is going to always be the best. So, you can have chocolate brownies from somebody. They're still chocolate brownies, but they're not as good as the ones that your grandma made, kind of thing. And that's what rebar, glass fiber rebar is. It's all about the recipe and how you cook it and bake it, and the end product is a reflection of that.
And I guess that's where MST bar really stands out, is the recipe and the formula of MST bar is what makes that grade 3 structural bar really possible.
Yes, comparing it across the board, it is amazing. My preference.
Just
Love it.
I would love to add one more comment. I think Alicia really pointed out well. Glass fiber and resin is not a new materials. If you go back to the history, glass fiber and rebar has been glass fiber and resin has been in the market for 80 years. This industry has been fighting corrosion. Boats, fiberglass yachts, fiberglass pipes, underground tanks. These materials has been out there for 80 years, outperforming steel in every case. Some of these tanks are in locations that the steel tanks cannot stay there more than 6 months, and you got a fiberglass tank sitting there for 30 years. What's really made MST bar unique is the process. So the glass is the same glass. Yes, there has been a lot of improvement in the quality. Resin is the same resin, and it's a new generation of the resin, but it's the process that makes the difference. As Alicia mentioned, it's the cooking recipe, the temperatures, your mixtures, and the combination of the sizings and so on that would makes this different.
Here's another question, and this one's kind of a more detailed question about the bar and its use. And it was asked by Alex Osborne 5629. The only question I have is, when you are cutting the bar, does it produce fiberglass dust? Borna, maybe you're the best one to answer that question as well.
Absolutely. Just every time you're removing a material, you're creating dust. It doesn't matter if it's a fiberglass, if it's concrete, if it's wood, if it's drywall, you are going to create dust. The question is that dust harmful for your body? The answer to that question has been published by the government of the United States. As I mentioned, fiberglass and resin is not a new material. If that would be a problem, believe me, they would ban the use of fiberglass and resin 80 years ago. So the question is, every time you cut this material, and when you cut this material, the dust coming out of that material is a solid round particle. Solid round particle, and the size is so small, is considered as dust, as a solid round dust. It's no different than cutting the concrete. As long as you have a dust mask to protect the dust to go directly in your body, and it's not harmful. Yes, you gotta cough it out, obviously, but as long as you have a dust mask, you're going to protect all your body and everything inside you. So at the end of the day, that dust coming off of the fiberglass rebar is not harmful. Yes, you need a mask, obviously. So as when you cut the concrete, you need a mask. But the misconception comes from fiberglass insulation. Fiberglass insulation, they do have a different microscopic structure. If you look at a fiberglass insulation, the shape has a little hook shape in it. So when you inhale them, yes, they're gonna go get stuck in your lung. Fiberglass dust coming from rebar is a solid round particle and considered as a solid dust.
Okay, that's a great explanation, Borna. Thanks for the understanding, because I think most people's experience with fiberglass is probably in an insulation application. Matt or Marty, you've been on job sites where the bar has been installed. You've probably had to do some cuts. Is the dust an issue? Is there more? Is there less than what you would normally expect on a job site using other materials?
So I can start there. The general answer to your question is it's not more, it's not less, it's about equal to, but it also comes down to how you cut it. My personal experience, I've tried to cut it with a Sawzall, standard wood Sawzall blade, metal blade, and I've also tried to cut it with a side grinder with a cutoff wheel, which is the thin wheel, not the thick grinding wheel. I have had way more success, way cleaner, way quicker cuts with a cutoff wheel on a 4-inch battery powered DeWalt side grinder. And one thing that I think Borna didn't state that I think should be stated, and you guys can confirm this, but my understanding is when you cut it, this dust is not considered a carcinogen. Is that correct?
Absolutely. Absolutely. That is not carcinogen. Yes, not harmful for your body.
So when cutting it, I've worn a N95 mask. I've worn your regular old mask without a filter, and I've cut it without a mask because, job sites, you get in a hurry. You've got your epoxy in the wall. Oh crap, I got to cut this before I put it in there. You don't put your mask on. I have had zero issues whatsoever. Now, obviously, PPE is always preferred on a job site, but in those instances that you don't perform your PPE properly, I haven't had any issues with it whatsoever.
And Jeff, I would like to add one more. If you're cutting 1 or 2 bars with a hand grinder, as Matt mentioned, not a problem. If suddenly you're having a 500 bundle of bars and you want to grab your, concrete saw, diamond blades, and cut through it, yes, you're going to create definitely more dust. You're cutting 1 foot bundle of, so how much dust? What we usually recommend, if you have a shop vac at the job site, literally just put a shop vac on the floor, and that shop vac going to grab as much as those dust possible. So you keep it cleaner, but absolutely not harmful.
And to elaborate on that bundle cut, we used a porta-band to cut a bundle, and all the dust fell straight to the ground. There was nothing floating whatsoever because a porta-band is, let's just be honest, it's a slow cut. It's not a fast cut.
Exactly.
Question number 3, it comes from Frederique 5974. And this is a good question. I think everyone's wanting to know this for sure. And he asks, Is it a one-to-one replacement or is some other formula involved? Last but not least, how much is the cost in comparison with iron rebar? I'll take a popcorn break and let you all do your thing. So let's let's address question number one first. Is it a one-to-one replacement or is there some other formula involved? Borna, I'm going to throw this one to you as well because you're the creator of it.
Jeff, this is $1 million question, meaning that in design words, everything is a variable. And everything is based on assumptions. You have two engineers with the same projects have two different designs because one is taking one assumptions and the other one is made. You can't say he's right or he's wrong. It's the assumptions that the designers make during design. One would consider this fixed, consider the other one a hinge, the other one consider it, both sides fixed. So at the end of the day, this is $1 million question. My answer to this question, over 95% of cases, it's a one-to-one ratio. You do not need to upsize, you do not need to downsize, it's just one-to-one ratio. There is 1 or 2% of the jobs that, yes, you can push it down to a lower rebar because, ultimate limit state design governing your design. There are certain designs that is purely governed by serviceability. You have deflections, you have a massive suspended slab with a gas pipe running underneath, and you don't want this gas pipe to deflect by 1/16 of an inch. So then that is a serviceability requirement. And yes, unfortunately, you can't use one-to-one. You might use 3%, 5% more rebar. It's not the end of the world. You're adding $100 more to the rebar, but you're saving a lot on the, corrosion and all the future maintenance. But for ICF word, because today we're focusing on ICF. In
Right.
ICF words, in a 3,000 or 4,000 square foot home, which you have a foundation wall with the little walls that is protecting the wind load, you're absolutely using one-to-one ratio. There is no need to upsize or low size. It's just one-to-one ratio reinforcement. So yes, the question to the answer for ICF word, it's a one-to-one. It depending on the size of, or the design, you have a designer that has designed the steel rebar to its limits. And when you're looking at that design, the steel design, you have too much deflection. So yes, when you go to fiberglass, well, yeah, you can't do it one-to-one because the structure with fiberglass will have a slightly higher movement, right? So at the end of the day, but you have another designer that designed the same wall with twice the amount of rebar because his assumptions are different. So when you go there, you're like, oh my God, how come Borna, I can use less rebar in this job, but more on that job? Because these are made with different assumptions. And at the end of the day, you never want your structure to fail. So you can never question any structural engineers or professional engineers' work because everybody is doing their own assumptions and design, and they have to follow the code.
Alicia, this is right in your wheelhouse as well. What's the experience that you have when you're working on drawings or reviewing them in a steel rebar conversion to MST? What do you find?
So I do have a equation. So I do a quick, it's a pretty quick conversion for me, but it does take experience to know, okay, this section, is it a compression governed concrete section or is it a tension governed concrete section? So for instance, anything that's going to have bending in it is going to be tension. And that typically is a one-to-one. So I do a lot of number 4s to 4EQ straight across. Well, that's not necessarily one-to-one because our 4EQ is considered a number 3 bar, but it is exactly like a number 4 in steel. So it is a one-to-one replacement for number 4s. Now when I'm going into compression elements, so if I'm looking at up here and it's 100% under compression, I look at it and it's actually a 2-to-1. So a number 5 can become a number 4. So it really depends on what the section is designed as and how it's functioning. And that just takes understanding 25 years of looking at structures, knowing, okay, that's in bending and tension and that's in compression. So for example, footings, top bars and footings are always in compression. They're always going to be a 2-to-1 replacement. Rebar on the bottom of a footing, is it really tension bar, or is it just for code requirements? So I'll look at that and I'm like, no, that's a tension, so it's a 1-to-1. No, it's just a code requirement. And then the ACI 440 is a little more generous in temperature and shrinkage steel. So I use those calcs for that, and that actually saves a lot of money on slab reinforcement. So that's not even close to 1-to-1. We can save a lot of money on just slab temperature and shrinkage steel because our bond strength is so much higher than steel. So there's all kinds of variables, like Borna was saying, that goes into, is it a 1-to-1, a 2-to-1, a 4-to-1? So it can be all over the board. But that's pretty much what I spend my day doing, is people going, I don't know how to engineer with this, but we want to use MST bar. So can you give me what MST bar is required to be? I'm going through the IRC right now and doing tables for everything in the IRC with MST bar. So any contractor can pick those up, and steel or MST, it's already designed for them.
And that's an important point there for any contractor. That is essentially the recipe you need to know if you are building it to the proper codes based on all that. The technical, is it tension, is it compression? That's where those tables are going to be a really good guide for any contractor building an ICF wall.
Jeff, I will add one more note just to finish this subject. If you're not sure, please contact an expert, Alicia, myself, one of our engineers. If your rebar is already to a minimum point, if your designer already specified a number 3 every 6 inches, every 12 inches, don't expect, this is my message to the audience, don't expect for us to be able to take it, to put it number 2 every 16 inches. That's already being minimum. But if you feel, oh my goodness, my wall is overly reinforced, and you think that there might be a room to do some reduction, or you're not certain, do not make that decision by yourself, and make sure you consult with an expert that has experience in this field, and then we can guide you properly.
Thanks, Borna. I think the point that I'm getting from both of you here is that, Borna, you had said probably 95 to 99% of the time, it is a 1-to-1 replacement. And when we're looking at an ICF construction and those walls, it's going to be pretty much exactly the same as steel components that you would normally do. And so that, combined with tables that provide contractors with the formula, the amount, that's really was going to get everybody rolling with MST bar in ICF walls.
Exactly.
And I'll elaborate on that a little bit more too. Not that Borna and Alicia aren't speaking to real life applications, but for me to speak to my exact applications, Marty had Alicia run most of the applications that I'm performing through her design work and tell us what she would recommend. An example of that would be on the castle walls. Alicia recommended horizontal bar 4EQ, which is 10 millimeter versus half inch. Oh, by the way, Borna, great job speaking in standard instead of metric when you were giving 1/16 of an inch there. Proud of you for that.
No problem.
But for me, on a 12-foot wall, instead of putting 6 pieces of bar in, I just put it every foot because the block is per foot. And I did 1 row of horizontal every feet so that every course had a horizontal piece of bar. For me, again, these are specifics to my jobs. That added maybe $150 worth of cost per wall. So for me and my applications, yes, Alicia's information was spot on, and it's what a structural engineer would have recommended for that application. I over-engineered it by adding $150 worth of cost. To me, that is well worth the over-engineering, knowing that this bar is just adding structure to your wall. And the application that I'm in, there may be some movements that none of us can assume. So why not over-engineer it for $150? To then go into the conversation of an ICF garage quote that we performed, customer wanted 6-inch walls, so they had more internal space. Well, the bar schedule came out that it would work, but their concern was the 50-foot wall on the backside, which was, this is an in-ground garage, okay? Well, instead of increasing the bar, it actually made more sense to increase the concrete thickness because the bar was already way stronger than the concrete. So by adding the mass of concrete, that allowed us to get it into the compressive state versus the tensile state, which made the bar work actually better in that application. And we didn't change the quantity of bar. And to be bluntly honest, we're still using half the amount of bar that would have went into that wall if it was metal, even though we're going to put the same amount because we're just going to go every row again. In the pool application, Alicia recommended vertical bar on the unbackfilled side, so it's got 100% of the water pressure, right? We got to retain 30,000 gallons of water in this wall. She recommended, per her math and her assumptions, bar on 16-inch centers. For $200, I can put it on 12-inch centers. Why not? Right? Again, these are smaller applications. If you're building a skyrise, you're going to have a lot more bar in your walls than what I'm going to have. But again, to over-engineer it, weigh those odds and cost. And like Borna said, if you're trying to mitigate your cost, you may do that originally with just the first starting point of the design that Alicia or anyone, an expert that would provide based off of the added strength that MST bar puts in your wall as a normal state.
Thanks, Matt.
Yeah, just to follow up on that.
He just told me that I don't over-engineer.
I
don't over-engineer. Give me the minimum, and he was comfortable putting more. No, I have to say I have a lot of peers that over-engineer, and I get complaints that there's too much in it. And then they look at my design, they're like, "Are you sure?" No, I always do. I always consider myself a contractor engineer, and I'm to give you what the code requires. And if you want to do more and beyond, good for you. But I'm giving you the bare minimum. So if it is a dollar to dollar, thing, that you can make that choice. But I'm never going to over-engineer and tell somebody to do more than's necessary.
And you're in the market for 30 years engineering. So for people that has a lot of doubt in their head, she is an expert for 30 years in FRP. So
Marty, you had a comment.
Yeah, I was just going to say, in the ICF world, our program is to get to where we're supplying charts that'll cover most of the projects. Outside of those charts, we want people to contact us to make sure that they're getting the correct information for these specific issues on their job site. And I can't be more supportive of how much. I can't be more impressed with the support we get from Alicia when I call and say, hey, all of a sudden I realize on the drawing there's one section of this building has an issue. That has to be outside of the charts. So by all means, the charts are generalized. We're making sure that you're covering most of the projects. Outside of the perimeters that are required for those charts, we want you to contact us so that we can help protect yourself with your build and make sure you have a successful build.
That's great. Thanks, Marty. Okay, let's move on to question 4. Question 4 is actually quite a couple questions all in one again, and it comes from Rob Bridges 78102 from the NYA Millennial channel. Question 1, and Borna, I think you'll take the lead on these as well. Again, first part of the question is: are all fiberglass rebar made the same? Second question, and this is maybe the follow-up as to what Rob is looking for, is: do they all have the same strength, shearing, and tension? And where can a person go to check out comparison of these things? I really do think these rebar have their place in new construction if the comparison is the same as steel. Old school guy, I have to convince myself before you can convince the homeowner. Can't wait for the Q&A. So Borna, first thing, are all fiberglass rebar made the same?
So Jeff, does all pen and pencils you buy off the market, they're made same? No. pens are made with the different formulas, with the different pen balls, the quality of the pen balls, the quality of the ink, how durable the ink is. There are so many parameters into making fiberglass rebar. What's the temperature? How do they make it? What's the process? How does the resin, how does the fibers get in there? Unfortunately, not all fiberglass rebars are equal. And in fact, not even the two of them are equal. You can't put two fiberglass rebars next to each other and say these two are the same materials because of the process. So it's going to go back to what Alicia mentioned, that cooking matrix, the cooking formula, where you have to take your formulas, your oven temperatures, your cookers, your polymers, your mixers. So not all fiberglass rebar, and it's primarily because of the process of how you make it. Some manufacturers have a different surface. I mean, you can grab MST bar, where MST bar have a totally deformed surface on the bar. If you have seen fiberglass rebar, MST bar, we have a total continuous deformation where this bar can adhere to concrete, and there is no way for you to take this bar out of a concrete if you don't break the concrete. Other products, they tend to adhere to concrete differently, and the bond strength. So this is what I always tell people. You can have the strongest concrete in the world, and you can have the strongest rebar in the world. We can make a concrete today with 9,000, 10,000 PSI, and you can have a rebar that is 250 KSI tensile strength. If these two doesn't bond well, it's absolutely useless. If these two does not transfer the shear forces from concrete to the rebar properly and keep the cracks closed, it's absolutely useless. So going back to answer this question, not two same fiberglass rebars are not made equally. They're totally different than each other. And where you have to find out, you have to go to their brochures, you have to do your due diligence, find out about the quality control programs, how does these materials made. So you have to do your due diligence to find out that that product is quality product, that product is being, there's a lot of things in there. The second part of the question, I think you mentioned, does all these bars have a similar mechanical performance? Tensile strength, shear strength, tension, shear. Again, unfortunately, no. Each product is different in tension, in shear, in compression. There's a big miscommunication out there. Oh, fiberglass rebar is not good in shear. Well, that's not true. MST bar perform as well as a steel in shear. We have, 250 megapascal, in imperial units, that's, 32, 33 KSI in a direct transfer shear. Steel, your same number, you're about 0.8, 0.7 of the yield strength, which is, 0.7 of 60 KSI. So, you're about 40. So we're very close the value of the shear to steel. In tension, we're 3 times stronger than steel, but not all fiberglass can be that strong. There are products that is only, 1.5 times stronger, some 2 times, some. So unfortunately, not all products are made equally. And for people have to do their due diligence, read about the different product to find out. And one of the most important part in rebar is bond strength. How would they adhere to concrete? Because that is your serviceability requirement on the crack widths. So the higher the bond, the smaller your crack. The smaller your crack, the higher the other values, because your concrete aggregates, your interlock, right? If you keep your crack as close as possible and these concrete aggregates are interlocked, you have a better shear performance, you have better punching shear performance. There's a lot of other things that gonna correlate to that bond strength.
Borna, I think what you're raising there is really the core of why we are trying to talk about MST bar so specifically. It's a great product. It is fiberglass rebar, but it it meets or exceeds all the qualifications or certifications that are required in order to do structural walls and buildings. And this is probably the biggest thing. One, contractors are switching to MST bar, and again, this is where we want to be specific that everything we're talking about here are the attributes and properties of MST bar, not necessarily just fiberglass rebar in general.
Absolutely. Absolutely.
Alicia, you've had to probably deal with this on different projects throughout your career. When someone says fiberglass rebar versus MST bar, how do you handle that in your drawings?
So it's the nice thing is that post-installed anchors kind of came before this and kind of set the standard. So any contractor who does any type of anchorage in concrete, whether it's epoxy anchors, wedge anchors, concrete screw anchors, there's tons on the market and they're not all the same. But contractors tend to have, okay, this is my go-to manufacturer. Like if they're going to pick a Hilti or a Simpson or a DeWalt, those are the three big ones that they're going to defer to all their epoxies and anchors. That's going to happen with rebar. They're not all the same, but the contractors are just going to have a connection with one or the other. I always, from my point of view, I worked at Simpson Strong Tie for 6 years. So I have an affinity for Simpson Strong Tie. I know the software really well. I know the products really well. I've seen it tested and developed. And that's kind of why MST, I've seen it tested and all the reports. So it's my go-to because I just know how it's going to behave. And I know the research that went into it. I can't say that about all the other bars. So I don't specify them. So what I do say is I, just like I do when I'm calling out an epoxy, I say I'm specifying a Simpson epoxy for this. And if you want to do a specific, if you want to substitute, you're going to have to go through your substitution requirements. Because if you substitute a Simpson anchor for a DeWalt, it doesn't perform the same. You might need a little bit more. And I'll do that for the contractors because they're my clients. But for the most part, I've never had a client say, "Oh, no, I don't like this. You have to change everything." So I usually ask up front. I design with Simpson and I design with MST, and they are fine with that. So as long as you're upfront with your contractors, I don't ever have anybody try to substitute. I do have people call me that have one of the other products going, "Hey, I can't get a hold of this. Can we substitute with yours? What do I need?" So that's the most common I get, is them asking me to substitute another product for ours. I never get somebody trying to get away from MST bar. So I just spec it in my drawings. This is what I'm designing with. This is what I'm using. And most contractors are okay with it. So I don't get pushback.
Yeah, great. Thanks, Alicia. Marty, maybe you can comment, just from being an installer of ICF for so many years, as well as just the training instructor for so many other ICF contractors. Reinforcement is a critical part of an ICF wall. How does that play in with MST bar and making sure you have the right product?
Well, one of the biggest things for me is, again, you say 30 some odd years in the business. And quite frankly, my reputation means everything to me. When I walk on an 18-story building, I'm there for a reason. I'm there to solve problems, make things happen. What's really been interesting for me is when I talk a one-to-one MST bar replacement, I simply say it's an MST bar, not just a GFRP bar. If you're going to switch from there, we need to investigate that bar to make sure it's correct for crack control, structural. So when we're using the MST bar for a structural bar, we had a case recently where we switched out some steel bar for MST bar in basically a 40+ foot high building. They were doing shear walls. There was no question. First of all, it was the weight issue and all those that we're going to get into later. All that happened, but more importantly, we know we can stand behind the fact that It's an MST product, documentation's there, testing's there. So when I present this on the job site, I know my name is being protected also, which maybe I'm being a little bit boisterous there, but the bottom line is I'm not an engineer. I don't have a license to protect, but I definitely have my 30-year plus reputation to protect. And that's where I use people like Borna and Alicia to help me protect that, because they have the information back me up on the job site. So on the job site, as we go farther and farther with this product and do more and more buildings, because of the backup, it's a lot easier for me to demand what they need to use, in my opinion. And again, without trying to boast myself up, what happens is when I give an opinion, quite often on these job sites, it's adhered to for the same reason as what Alicia does her opinions, because she has the background and experience.
For our next question, we have a special guest that's joining us to get the perspective of another seasoned ICF contractor whose installation teams are currently knee-deep in several ICF builds around the country right now. Tim Pinter is a longtime ICF installer that is currently working on a large ICF residential project in the mountains of Durango, Colorado. Through his 18 years of experience, Tim has always used steel rebar, but you've recently made the switch to MST bar, including the current mountain project that you're on. Tim, thanks for joining us for this question. So question 5 is, what would a typical insulated concrete form installer experience using MST bar on a job site be in comparison to steel rebar? And we thought this was a great question for you, Tim, because you are basically, you've done steel for so long and now you're switching to MST bar. We'd love to know what your experience is, Tim.
Yeah, so I guess I'll contrast a few things for you here, and we train installers all around the country. We're Department of Defense contractors, SMEs, subject matter experts. So knowing our materials that go in here and how they react with everything is incredibly valuable. I took a few notes just listening to some of the other points that were made, and again, I'm going to come from a different perspective just because of what I do and where I work. But as far as safety goes, particularly on government jobs or Department of Defense jobs, the safety aspect of this is much, much easier to deal with than steel. And yes, you want to wear a mask for that. However, with steel, the number 1 and number 2 injuries that we see on an ICF job is the obvious danger of people falling. But the largest ones we see are massive lacerations or cuts from the very sharp edges of steel that have been cut off. They're handing them around the property. They're lifting them up, scaffolding. They're lifting these things over their head. As an ICF installer, you have to remember, when we drop verts, so let's say I have a building and I have 400 verts I have to do. I'm now lifting a number 5 rebar over my head, 16, 12 feet in the air, a number 5 rebar with sharp edges, and I'm dropping that into the wall, and I'm doing that over and over and over and over again. And dealing with those razor sharp edges from cutting steel is actually what we've seen as our largest percent of injuries is from the cuts from those sharp edges of steel, either the process of cutting the steel or after the steel is cut and moving that sharp rebar around the job site. And yes, we have PPE, we have to have gloves, things like that. But anyone who's worked with a lot of rebar knows it'll cut your pants like nothing. So that's or your sleeve edge. I mean, it'll go through it like it's not even there.
I won't show the scars today.
What?
Thanks.
So that was another thing. And then as far as the safety, again, on a lot of these jobs, if you're cutting steel, you have to have fire extinguishers by you at all times, because you're shooting flame every time you're cutting the steel. If you're not using a snapper, if you're using something that's actually some kind of abrasion, it's going to shoot sparks everywhere. I probably shouldn't even admit this, but I've watched one of our guys literally start his entire pants on fire trying to cut a bunk, didn't have his legs spread apart enough. I realize these are real world applications, and someone says, well, that should never happen, but it does. And so we've had that happen as well. So I would say for the fire aspects of it, and wearing a mask for the fiberglass getting cut, everyone should be wearing a mask when they're cutting anything, like that on site. But I find that the MST bar is infinitely safer than working with steel on a job site. And for what it's worth, the worst injury I have ever had in my 20 plus years of construction was indeed on an ICF job, cutting steel, and some of the sparks embedded into my skin. I didn't realize they'd had an infection set in, and I had a pretty bad infection from cutting the steel. Again, the safety aspect of having something that's easy, fast to move around and cut is incredibly important. So, couple of the points that I would throw out there just from the very, very real world angle of things. Obviously moving it around, it's so much lighter. Your manpower goes way down when one guy can grab 10, 20, pieces of product and move them across the site. There are specific weights on different jobs that you have to use 2 men if you've gone over a certain weight. And so now you're doubling your manpower. Again, I realize some of these young kids, they're just, how many can I carry? But there are actual rules to that on a lot of jobs. I'm from Wisconsin, so I'm a northerner. And so a lot of people down south, they don't understand. Cold has challenges. And everybody hates the steel job because no matter what gloves I put on them, their hands are actually freezing off after handling that stuff. And if you didn't ever work in the cold, you can't understand what this means. But for my guys, they hate whoever has to touch the steel for the next 3 to 4 hours cutting it, just because they're frozen.
And go the polar
so
opposite.
that's a perk from the north.
Go the polar opposite.
Oh yeah.
The people in the south, I've had burn marks here from packing steel rebar on my shoulder. So it's the polar opposite is the exact same problem.
Yeah, that's interesting. Mm-hmm. So next point I wanted to make from an installer aspect is you don't need any special tools. We have thousands and thousands of dollars of rebar benders, cutters, every kind of thing that you can have out there. They're heavy, they're expensive, and they break often. Where all I need is a diamond blade on an angle grinder, and we zip through this MST bar. I have a video of us cutting 20 bars in probably under 15 seconds. Just laying it out, shoving it against the wall at the length you want to cut, and fire away on your 500 cuts you have to make. So that's been a huge blessing of the MST bars, just the speed and ease that it cuts. Also, and this was one for the engineer. I'm not an engineer. I'm not qualified to tell someone what to put in or not put in the wall. So I depend on those engineers. And I was extremely impressed on our last job when we were able to simply wire tie off bundles of the MST bar where steel was called out for a larger number. And some of that steel that they call out, a number 7 or a number 8, it's not even readily available. You can't even get it. So if you are able to take your MST bar and bundle 2 of them or 4 of them in particular cases to accommodate that. Just the time of sourcing that and getting it can be extremely difficult. And then also with ICF, depending on what blocks you use, we're certified in many blocks, but a lot of them come with their webs having little saddles and things that you slide your rebar into. And the MST bar being able to have smaller diameter doesn't run into as often as of them not fitting. For example, normal ICF blocks will not even let you take a number 6 bar in it. You have to cut out the saddles to lay that in. So that's a nice perk to the MST bar. Also, and then I get a little technical, and I realize I can be a concrete geek. I'm a 3rd generation concrete family, and my previous life I was a chemistry teacher and a math teacher. So I do realize what happens really often in the ICF world is you get an engineer that maybe doesn't know the industry that well, and when they drew something up on their computer, it looked really great, and theoretically it was going to work fantastic, and then in the real world that's never going to work. And one of the things that I see really often in the ICF world, our biggest concern, besides blowing things out, you got to make sure you're braced up right, but after that, the real concern that would keep you up at night, it would be you haven't consolidated your concrete properly and you have voids. And very oftentimes with rebar, more isn't more. If you can't get the stone and the Portland and the concrete to flow because you have put so much crap in that wall, then you're actually risking some serious structural. And the MST bar having that 4 EQ, it might sound like something small, but that allowing more room for your aggregate and your concrete to flow through is a huge deal in the real world, in the real field. When the concrete truck did get lost for an hour and a half trying to get up the mountain at 9,000 feet, and the concrete did come a little hot, and you have to make that call whether you're sending it back or it can flow through. And those are real world applications that happen in the ICF industry.
Or you ordered at a 6 and it comes in at a 4.
Exactly.
Tim, those are great thoughts. I mean, those are the experiences that truly are real world. It's not something that we would put on a brochure or a website about how to use it or the benefits of it. But, you know, when you are in the moment and you are handling it, whether it's freezing cold or, you know, super hot, those are the things that actually matter. And those are the things that do affect productivity, that usually go unnoticed or are intangible. So those are really great thoughts, Tim. I really appreciate those comments, because everything we're talking about here is great, and it's lighter, it's stronger, great product, but it's really cool to see in the moment how it actually changes the crew and how they work on the job site.
And I'd like to make two quick points to some really good points that Tim made. The cutting of the metal bar, you always create a burr on the bottom side of your cut. I don't care if you're using a demo saw. I don't care if you're using a cutoff wheel. I don't care if you're using a Sawzall blade. You're going to create a burr. With MST bar, there is no burr. So that mitigates straight from the beginning, no sharp edge that's going to cut into you. As he stated, yes, metal bar after it's been cut with any of those fashions will cut straight through your jeans, firsthand experience. And then in regards to the equipment and the lighter weight of MST bar, the top of my castle build is 26 feet tall. We were able to grab a bundle with one hand, 20 sticks of 4 EQ, and drag it up the steps. I would have had to have been required to either take one bar at a time or have a sky track there to get it up to the 26 foot to put in our verticals. Whereas with the MST bar, since it is a quarter of the weight of steel, we were able to bring 20 up at a time, hand them up the wall, pick them up over my head, and put them down in that 12-foot tall wall. So he is spot on with his points there. It is just so much greater to work with.
Perfect. Tim, thanks so much for joining us for that question. Appreciate your input, and good luck on your projects there in the mountain.
Thank you.
Yeah,
Absolutely.
yeah, we need to have a conversation about the mountains, by the way. I need your
Oh
number.
man, this place is crazy. I'll share some things with you. Oh, one last thing I wanted to tell you. I just had to do it 2 days ago. Inspector called for a particular pipe. I won't explain exactly why they needed it. I had to core this freaking wall out, and I didn't have MST bar in it, and I was just dying coring, and I hit the freaking horizontal number 5 bar. I hit the vertical number 5 bar, and I just happened to get lucky enough to hit the top anchor bolt holding the top sill plate in. And I was just thinking, if I just had MST bar, I would have just flown through this thing. But it was absolute hell having to core that thing afterwards with the steel. So just one more last application. If you ever got to core it.
On the other side of that wall, I had a 4-inch core I had to do. We forgot a penetration, and I hit 2 pieces of bar and ended up with a hammer drill to get up and over the bar. And if MST bar would have been in these ICF walls, that would have been a non-issue, 100%.
Yep. Yeah. Yeah. So
that's real life right there.
That is a good point. That is a
very engineers do a great job. However, they can't think of all penetrations, and almost every ICF job, the customer makes a change and it needs a penetration. Well, your wall's poured. Well, I mean, come on, you can't change it without boring, right, coring, or notching. Those are your only options.
Yeah, that's great. Perfect. Thanks, Tim. Appreciate it.
You bet.
Have a great day.
You too.
Question number 6. This one is a compilation that came through on a bunch of different comments. So we just kind of compiled it together. Marty, we're going to point this one at you. Question is, what install differences between what we are used to with steel rebar? Also, is the same overlap required? And what about using MST bar for footings in ICF walls?
The best way to do this is it's installed exactly the same as steel. You're going to use in the ICF walls, you're going to put your horizontals in as you go up the wall, and then you're going to drop your verticals in from the top. Anytime you overlap steel or you run steel and you have to overlap lengths, you need an overlap distance. The general rule of thumb is 40 times the diameter of the bar. We maintain the same thing. If we're on a particular project and somebody wants 50, we can do with that. But in general, it's the exact same as steel is what we use. And then as far as the footings, we use them in the footings. It's interesting. One of the things just happened recently for me. We were gonna tie the vertical bars in, the dowels in for the footings, and the homeowner wanted to use L bars. So I talked to Borna months and months ago about just using straight bars because of the bonding strength. And then I went one step farther, and what we end up doing, instead of trying to wet set these all afterwards vertically, I literally pound them in the ground through the middle of my footing because it's not going to affect anything, and left them sticking straight up. And it worked very, very well. So there's so many things that are identical to steel, but there's so many benefits with the quarter of the weight, the handling around the job site, the cutting. And now here I can literally put bar into the dirt below the concrete footing, come up through. I'm not saying that's the best way to do it, but I'm saying it was possible because it's not going to deteriorate. You don't have to worry about the rust, et cetera, et cetera, et cetera. There's so many little things. I joke with people and say, I use my cutoffs on the farm for electric wire fences, posts. You stick them in the ground and hook your wire fence to it. So the fact that you can put these into the ground, carry on with your project, it just helped us. So in general, 40 times the diameter, same placement as steel, and just move on up your walls.
Matt, you're in the middle of a build right now. How did that all work in real life?
Yeah, so footing wise, a little past experience, and Alicia might be able to elaborate on this some as well. But the whole point of the rebar in a footing is to get it in the bottom third of the thickness of your concrete, right? So whenever we go to do that, a lot of times in a 2 foot wide, 8 inch thick footing, we will use 2 half-inch metal bar, right? Where in this case, you've got the same in MST, it's just an MST bar. So we put 2 bar in there, spaced equally off the edge of the footing. And this is a formadrain application. And then you have the hangers, you just lay the bar in there. And then to Marty's point, I've done it both ways. We have even used metal bar and beat it into the ground, knowing that it is going to corrode over time, but we're not reliant on that short 6-inch section that's in the dirt. We're reliant on that vertical section that's in the 8 inches of concrete, plus the 24 inches that's sticking out. What I found with the MST bar is it has a much larger range of applications. People can go back on the channel NY Millennial and see this, but in my application, I was putting formadrain on top of compacted rock, on top of concrete that was under the compacted rock. So I was going to pound the rebar into the ground, but I was hitting concrete. So I hammer drilled some holes. Where the real odd application came into play was my metal stakes for my formadrain. You can't bore a hole 1 inch in diameter because these flat bar is 1 inch wide. Well, now it's just a flat bar in a hole. It's not going to hold anything. Whereas I could hammer drill a 1/2 inch hole into the concrete and drive the MST fiberglass bar right down into that hole. And it actually had a pull strength to it. It was very hard to get out of that hole. And the next ease of use was I was able to drill holes through the fiberglass MST bar and put screws through it as my grade stake for my formadrain. I wouldn't have been able to do that in 3 days with metal bar. It would have taken me 400 drill bits, 700 batteries, and a bunch of time to get 2 holes drilled in metal bar where and I know this is not the application for MST bar, but real world experience, you literally use it for anything. Just as Marty stated, you use it for a fence post if you want to. It's just more usable on the job site than metal, is how I would answer that question. And to the Alicia point, when it comes to a footing, the bottom third mentioned earlier, it also comes down to the dirt quality that you have. In some cases, you need a soil test. If you have sandy soils, 2 bar, which would be the engineered minimum for an 8-inch footing and a 20-foot tall ICF wall, you may need 3 or 4 bar to ensure that it doesn't sink because the ground is not supportive. So there's a couple of different outliers to that application that have some very key specifics to support your structure.
Yeah, one thing I do have to mention about foundations is because the bar is non-magnetic and it does not transfer any electrical, it cannot be used for grounding. So that is something that builders need to be aware of, is they have to find another way to ground their electrical because they can't ground it with an MST bar. But that's not an issue. You just have to find another way to do it, or just throw in a bar in there for just grounding.
Right.
But,
one piece of
yeah. So because you only ground really in one location anyways, but that's just something to be aware of. Is a grounding bar, it doesn't work. But yeah, your foundations, I always say, you always be a little conservative on your foundations. It's the place where you do want to over engineer, because settlement is the worst thing you can have to a building. So if you don't know, ask. And if you can't get a soils report, I always say grade it. You make sure you bring in fill, because if you're putting it on well-graded fill instead of native ground, it's going to make a world of difference. So, but yeah, you're right. Your soil that you're sitting your foundation on is super critical.
And to elaborate on your settlement is an issue with a structure. That's not just ICF. That's any structure that settlement is a big deal.
Yeah. You can look at buildings that collapsed overseas because the foundations held.
Mm-hmm.
Matt, we're going to keep going on with you here. Question number 7 from S'more 45 is, so a long piece of MST is bendable, it just won't stay bent.
Yeah, so they picked that up from the video in which Marty was on site, and he took a 20-foot stick and he bent it back on itself and he let it go and it sprung back to its original state because it wants to stay straight, right? So the reason Marty pointed that out is if you are kerfing your ICF and you are doing a curved wall, it is very difficult to get steel in a curved state because of its weight, because of its nature, whereas this bar is flexible. So if you had a bay window that your ICF had to curve out into because you had a curved window, the MST bar is going to fit right down into those saddles, as Tim mentioned earlier. And that MST bar is going to form to that shape much easier than steel, but it still wants to stay straight. However, it can be bent if you get with MST and you need saddles, you need 90s for your corners, you need your C's for your lintels that you're going to put in over top of, or S's. There's several different shapes that people use in today's world. It can be bent into a fixed shape. Marty was just trying to show that it is a pliable bar. It's not something that's just going to, if I hold this pencil out, it stays perfectly straight, but it's only 6 inches long, right? So that was kind of the purpose of that, but also not to fail to mention that you can get it in a fixed shape from MST bar directly.
Perfect. Marty, any comments?
I do have some.
I was just gonna confirm that we cannot bend it on site is maybe the point that has to be very
Job
clear.
site. Yeah.
And that's what you were saying, Matt. It cannot be bent on the job site. We can pre-order bent geometric shapes, but again, that's what I was proving was it also has part of my demonstration on the site there was I have places where the job site, a skid steer or whatever will run over a bar and it bends it. Well, it stays bent. So sometimes you're throwing bar away or trying to figure out where else to use it. Whereas on the job site, you run over an MST bar, it may bend to contour from the bend, but then it snaps back to its original state for you.
Great.
Yeah, this is why MST bar does so well in pools, because they're minor slopes. They're not, so I don't call it bent bars, I call them fabricated bars, because you can bend the MST bars to shape and then in your formwork and cast it that way. But if you need a fabricated bar in a specific shape, that is custom, ordered. But it does amazing for anything that does have something that's a little concave or convex that you're casting. So it's a really flexible to use on site.
Great. Thanks, Alicia. Okay, question 8. This one is been asked a lot on all the channels, and obviously it's an important factor, and it has to do with cost. And the question is, what is the cost of using MST bar compared to steel rebar? Matt, let's get your perspective from someone who has recently purchased rebar and kind of done that comparison on actually a couple different projects. I think we want to hear your perspective. The issue with this is that steel rebar fluctuates in price, and it fluctuates in just in general, but then also there's a regional factor to it as well. So it's a bit challenging to exactly say, okay, what is the cost? But Matt, nevertheless, love to hear your perspective from a contractor to hear what was your experience very recently.
Yeah, so I can't really speak to foot price or 20-foot stick price because I'm in Southern Indiana and someone out in Idaho or Colorado or Wisconsin may have a totally different foot price. Okay. What I can say is I quoted the ICF pool, let's just say 6 months ago. Okay. We recently got bar in 2 months ago, and I confirmed my steel pricing prior to, and I also confirm my steel pricing as of the 14th of this month. What I can speak to is, in my applications, per the designs that I was given by Alicia and Marty for these specific applications, is the steel bar was roughly 20% more in cost. And that's after I increased the amount of bar that went into the wall based off of Alicia's recommendations for the water retention. It was still 20% more, and I used more MST bar than was recommended. The other thing that I would like to point out is 6 months ago when I provided this quote compared to November 14th, whenever I got today's pricing, if you will, on steel 1/2-inch bar, it was 7% less 6 months ago when I performed the quote compared to 6 months later when I would have purchased the product. That's a short time frame.
Yeah. Yeah, that's good.
And let me state one more thing real quick. MST bar was the exact same price when I quoted it as to when I purchased it. And that is facts. That's what that is.
Marty, you're not only the technical advisor for G2 and for MST bar, but you've been involved in many builds as well. From cost perspectives, how does it work out with MST bar? One point that I think is worth noting is just the consistency versus the price of steel. What's your experience?
So exactly that. It's the cost will geographically change. One of the interesting things that's happened recently was we've told people said, well, I can get a truckload of steel for this amount. And then they say, okay, what about a truckload of MST bar? Well, first of all, it's 3.5 times more bar on the truck. So that's why now you're saving 2.5 truckloads of freight probably. But more importantly, one of the things that I kind of play with on the job site or in a meeting is, how can you not afford to use MST bar? Because it's not just the cost of the bar, it's handling the bar, it's all those things on site, it's all those other things that happen. But when you actually look at it, in most cases, the number 10M number 3 bar in the ICF world tends to be very close on price, maybe a little bit less in some areas. It's almost a 1-to-1 par in most cases. More and more, the MST bar, the biggest issue for me is it's been consistent pricing, whereas the steel bar is up and down based on it's a commodity, so it's going to jump up and down. So when I say that as a joke, I'm basically making people think it's the same as the ICF world. When you're building with ICF, people, I would argue over the years, would say to me, well, I can just go ahead and do my foundation and because you're that much more expensive than a poured cast in place concrete foundation. And I'll say, yeah, but did you include your insulation package? Because we're already doing all that. So it's the same, almost the same principle with the MST bar. What is the real cost? The manpower, less labor. You get into the cutting factors, you get into handling it around the job site, you get into the safety issues that Tim brought up many times. I personally have a gash on my left leg that I to this day, I still don't know how I got it. It was a dowel and a footing, a steel dowel and a footing. It never cut my pants, but it cut my leg. So what we figured happened was one of the little burrs popped through my pants and that burr cut my leg. I had a warm, wet foot and didn't know what was going on. It was because my boot was full of blood, literally. I poured the blood out of my boot later. But anyway, I'm kind of off topic on the pricing. The pricing's in the actual cost of the bar. It's very similar, or in most cases nowadays, it's somewhat less than the actual steel bar when you figure it out. Because especially if you include the fact that it's 3.5 times on a truck, and the distributors are buying truckloads, they can pass that on to the end user. It's a general averaging of the bar. So in the real world, you do your homework, work it out, you're going to find it's very, very cost effective.
Borna, I know you want something to mention here too, but before you add your comment, I was just I was thinking about how when you're buying MST bar, every batch that comes out of the factory is tested and insured for quality. And so if you're buying a bar today, tomorrow, next year, whenever, you know that that bar is coming out, it's been tested, it has the proper attributes that we are claiming MST bar does. In the case of steel, yes, steel is graded and should be tested, but it's not necessarily 100% that you know where that steel came from and whether it actually has the quality that it is presenting as. Maybe you can comment on that, Borna, as well as what your thought was.
So I'm gonna wrap up the costing and then move to the next question that you had, Jeff. You know, just to wrap up the costing, one thing that people would not notice, and I'm gonna ask that question from Max, because he has done a job, and I'm gonna ask this question. Max, how much do you think in percentage was the cost of your rebar in the overall projects you did, including your foam, your concrete, the workers, the laborers, the lumbers, the shingles, everything? You tell me percentage-wise, what was the cost of the rebar in your job?
I can't give you a full percent. Does that answer your question?
Yes, yes. And because this cost is typically so low in overall budget, when they're building a 80-story building, the cost of the rebar is less than 3 to 4, maybe 5%, depending on the type. So if that 5% drop by 0.1 or goes up by 0.1, at the end of the day, in the overall project, you're seeing a very little difference. In fact, you probably won't even notice the difference. But as Matt mentioned, hey, if you add 2 more bar here, 5 more bar there, hey, you're gonna build a bomb shelter for your family. You got to build something that is strong, that can withstand anything, you know. So I hope we can wrap up the costing aspect, because yes, the price of fiberglass and steel are equivalent, but at the end of the day, I think what's going to have a really impact is your labor cost, is how fast the process, safety at the job site, and so many other things. All right, so I'm going to move to the next question. As Jeff
Before you do, Borna, before you do, I'm going to interrupt you for just a second. I'm going to give everybody real world number here. Okay. I stated 20% earlier. The pool walls only, if I would have used steel versus MST bar, it would have been $1,300 more to use steel.
Wow.
That's a small application, which still is not a very big percentage of the cost, but it's still $1,300 that a contractor can then decide, do I win the bid because I could save $1,300, or can I put $1,300 in my workers' pockets as profit and my own pocket as profit, right? That's the only number I'm going to give.
My main audience about that was the owners. You're right. Contractors, obviously, when you want to be competitive, you want to shave $1,000, $2,000, especially if you're just a contractor to do the foundation walls or the basements or the footings. So definitely you're 100% right. Your audience is to the contractors, and my audience is to the owners. If you are the owner, do not pinch that contractor to go minimum, because the cost of the rebar overall would be very little in overall project. But for the contractors that doing just the foundation walls, yes, he only have 3 components in there. But for the owner that is responsible for the overall project, that rebar cost is nothing. He won't even see it in his book.
That's
now
great.
we can be done with price conversation.
Okay. All right.
Question 9. Actually, Alicia, maybe you want to address this one. And it's asked by Steve Push. What will fire do to the rebar? Is it toxic due to high heat?
Maybe I can answer that one. Alicia. Yeah, I can get there, and Alicia can go with her input. We are dealing with a system. People don't confuse a material and a system. We are selling reinforced concrete. We're not selling rebar. This rebar is meant to go inside a concrete. So at the end of the day, it's a reinforced concrete. The concrete itself is one of the best insulation materials for fire known in the human history. So technically, the concrete itself is the enough cover concrete, which according to ACI, according to CSA, depending on where you are in the world and which code you use, you have a minimum cover concrete, which is about 1.5 inches or 40 millimeter. Now I'm learning to go imperial and metric at the same time. Yes. So getting back, that minimum cover concrete provide enough protection to your rebar for the heat or fire to never get your rebar to the burning point. So that's number one for people to understand that the cover concrete, that's why in a very high fire application, we recommend to go to even 2 inches of cover concrete because you really want to get there. However, this test has been done by ASTM, according to ASTM E119, actual parking garage slab made with fiberglass rebar, direct fire underneath inside the chamber. And it's actually that concrete, that slab was able to take over 3 hours of fire rating with the actual live load. So they actually loaded the slab with the live load. They put a fire and the slab was able to take, over 3 hours of fire rating. And the reason was simple, was because even if the polymer, so now you look at my hands, if you hear the noise I'm going to play for you, 85% of this material is made by glass, guys. So 85% of this material is glass. So that means even that 15% of the resin get degraded at the very high temperature, still glass is not going to go anywhere. And these glass strands are going to act like a cable, like a post-tension cable in your slab on your wall, and they won't let that to fail. So all you need is, by building code, you need 2 hours of fire rating to be able to evacuate, or firefighters to get there, to put the fire down, or so on. And with fiberglass rebar, you're going to get your 2 hours in. If not, you're going to get 3 hours with the proper what we call detailing. For example, we can get a little bit more technical into this. If you have a slab, right? If this is your slab, you do not want to lap the bar in this area. So why? Because the fire is typically going to hit the middle of your slab, and the lapland, that joint, would be the first one that's going to open up. So what we recommend, if you have a compartment, if you have a room, make sure this bar goes all over your wall, and you tie the next wall all over this one. And this will protect the cold zone, what we call the cold zone. So the end of the bar would stay cool and would grab the concrete, so it start acting like a cable inside. So proper detailing, you can actually get more than 3 hours of fire rating.
Yeah, so ACI, it has a great commentary on it. So if anybody does have ACI 440, ACI, the old document that's not code, goes into a lot more in detail, and they've got a lot of the references to all the research that was done. So it's not that they just threw it out there and let us go hog wild with the bar. There's a lot of R&D that's been done on this. And like Borna said, the tensile capacity, you have to get the bar over 350 degrees hot. It can't burn because there's no oxygen in the concrete to actually burn the bar. So you have to have oxygen there to feed the fire. So toxicity doesn't really come into play. The toxic's going to be whatever's in that you're burning off in the concrete mix. So whatever additives you have are going to be the toxic part of it. And so a lot of the research is saying about 20 to 30% of the tensile capacity will be reduced. So what you're just going to see is it sag. So it's not going to collapse and cause any major issues. And the problem with steel is when steel does this, steel continues to degrade after it hits that transition point. So steel, so the way they behave are very different, because MST bar continues to carry load until it breaks. Steel will carry load to a point where it just softens and then it fails. So once you heat it up, it's already softened. So it's going to continue till it fails, where MST bar, it's not failed yet, so it's still going to carry load. So they're two different behaviors, but really what the consensus is, design MST bar with the same cover as steel, and it's going to perform better because it's still going to carry load even after a fire.
In real life situation, this is not a concrete home. This is not an ICF home. It is actually a cinder block home. And unfortunately, I had to go perform a quote to demo this home because it just went through a house fire. You may not have your styrofoam left. You may not have your wood structure left, but the cinder blocks, which would simulate an ICF wall, are still standing perfectly vertical, unscathed, unhurt. Are they useful? No. They've been through a high temperature application. However, it's not going to make it to the rebar.
Yeah, great real life example there too, Matt. Question 10, let's keep moving on. And this one is again more probably for Borna and Alicia, but how does MST bar differ from steel rebar in regard to how the concrete reacts and bonds with the actual bar? Also, what is the difference in the tensile shear strength of MST bar compared to steel?
So tensile capacity. So the best way, I always tell people that rebar and steel, steel rebar and MST, I always compare it to a paper clip and a rubber band.
Okay.
So a paper clip, you can only do so much before you break your paper clip. So you can bend it and manipulate, and then it snaps and it's no good. So MST is more like a rubber band. It will stretch and pop back until what we call is creep. And you've kind of stretched it out to the point where it's not usable. But that rubber band gets a lot more use than that paper clip ever does. So that's what I always say is they perform very differently. So kind of have that in your mind as paper clip versus a rubber band. But tensile capacity, you can stretch that rubber band. Can you really stretch that paper clip very far and snap it back? No. So that kind of keeps into mind that MST bar has a lot more stretch in it than rebar. Shear, it's about equivalent. So I think about when I'm doing ties and hoops and things like that, it's usually a 1-to-1 because they're almost identical. Dowels, same. I don't have an issue doing a 1-to-1 for dowels. So those are the two big things, but the performance when you put it in the concrete is the biggest bang for your buck. So you can load it, and because it's a rubber band, it snaps right back. It doesn't stay deformed. So that's why bridges use it all over the place, because you're driving over it, and as soon as that semi leaves it, it comes right back to where it was when that semi drove over it. So what's nice is if you have a windstorm, it might blow, but it snaps right back after that windstorm's gone. So you can push, steel, you can push so far and it stays deformed. So that's just one thing to kind of to be aware of. Is it might feel a little more bouncy because the bar is more flexible, but it comes right back to shape, which is what I love about it. So those are the two things, just how it performs and understanding its performance. So I don't like to say steel and MST, they are used for the same thing, but they have very different performances.
I can see some of my subscribers taking a paper clip and saying 10 and it broke, and then going till tomorrow, right?
Yeah, exactly. But that's really the way, because if you think about that, paper clip is made from some type of a steel material,
Yep.
And that rubber band is made from some type of an epoxy material. And that's a very good hands-on representation of the two different types.
That's a
Your
great
arms are going to get
decision.
tired of pulling on the rubber band. I can tell you that right now.
Thanks, Alicia.
You have to pull pretty hard to break it.
Yes.
It's analogies like that that stick in our minds, and we can really grasp the differences between what MST bar would be and what steel is. That's great.
And getting back, Jeff, there is no reaction between MST bar and concrete. So there is absolutely no reaction. This material, how does it bond? It mechanically lock inside. So think about, you have a Simpson strong tie, or you have a concrete, the blue, what is the name of those concrete blue, not screw that you screw them?
Tapcon.
Tapcon. So think about, you have a Tapcon and you're going inside your concrete. How can you get that Tapcon out? Well, you have to break the concrete, because good luck taking that. It's
Or
because,
unscrew it.
yes, because it's so hard, and that material is interlocked inside that concrete that there's no way you can take it out. And there's no reaction. You can put salt, you can put water, you can put ammonia, whatever you want in there, and there is no reaction with the material. So absolutely.
Well, that also is another point that could have been made on, is all rebar made the same? The answer is no. I may or may not have went to the local hardware store to see what fiberglass rebar they had. And I'm here to tell you, it is not made the same. And that's an exact point right there.
Well, I like to say that there's the generic bar and then there's structural bar. Don't get the two confused. You should never use something off the shelf at a Home Depot or a Lowe's, because it's not necessarily a structural bar. So you can't go and just replace a rebar with it. So that's one thing I always say is MST is a structural bar. It can be used in anything that you use concrete in a structure. Because you can do a lot of concrete work. You can build a patio and you can go hog wild with whatever you find at your Home Depot, because it's not really a structural application. But when you're building a house and walls and foundations, you want a structural bar that lasts that it will actually outlive the concrete it's embedded in.
So for those that don't understand that comment, Alicia, a patio is only crack control. That's all the rebar is for, to mitigate cracking in that slab. That's it.
Mm-hmm.
All right, that is question 10. We have two more questions. We'll try and get through these quickly. This next question is really more just an attribute of MST. It may not really affect an ICF build, but it's probably worth just talking about, because it does speak to some of the properties of the bar. And again, this is asked by CC Swede, we'll call the commenter, and it's, what about using MST bar in seawater? Seems like it would be a better fit to use fiberglass rebar. Does salt have any bad effects?
So MST bar is taking over the Florida coastline. So we have building departments that are requiring MST bar in their seawalls because it does so well. And there's been ACI, there's some research documents on the website that you can go and look at, is using salt water actually makes a stronger concrete. So when you're using a stronger concrete and you're putting a bar that can actually take salt without corroding, no alkalides. So the big thing that I always tell concrete guys is you don't need potable water. So because you don't have the issues of a reaction corroding the bar while it's in the concrete. So you go for and just use whatever water you need that makes a strong concrete. Don't worry about it being potable. But there's research out there that I think with time, you're going to start seeing people use salt water because you're getting a better concrete. And you have a reinforcement now that can strengthen that concrete and tension and get an even better product. So I see this, this is a huge issue for global warming with the rising, not going to get political or anything, but with the rising ocean, you're going to get a lot more seawalls that need to be built this is the perfect reinforcement using salt water.
Yeah.
There's a small disclaimer that I need to make, and Alicia is 100% right. And the disclaimer is very simple. It's the concrete that they're using should be alkaline resistant concrete. There are different grades of concrete, and concrete have sand and aggregate in them. So all the contractor have to verify to make sure that cement bag they're buying has an alkaline resistant aggregate, because you don't want the aggregate itself to react with the salt. That's the only thing. If you are certain that you're using what they call the secret is the formula for the type of a cement that has an alkaline resistant aggregate, then you can just go grab water from the ocean, put MST bar, and you're done. So I just wanted to, and Alicia mentioned one thing that I don't think it was part of the question, that is about sustainability and resiliency. You know, today, one of the biggest focus on MST bar is about sustainability and resilience. Is about, you know, our mother nature, the environment. And that's something that people don't care these days. You know, people don't care. I'm sure there are lots of people, if you're entitled, if you're in ICF world, you definitely care about energy saving. So you are already have that mindset in you that you want to build better, you want to be more durable, resilient, save energy. And MST bar is about lower energy to produce. It's all about efficiency, lower transportation because it's 4 times lighter, and it's all about resilience and durability and sustainability. That's where it drives us forward.
Which goes hand in hand with ICF, because that's what ICF is providing. So it's you're putting 2 peas together. So you have 2 peas in a pod. They're both doing the exact same thing.
Yeah, Borna, as you know, I've been in the MST bar facility multiple times, and you could mistake it for a warehouse that has shelves with just skids of boxes in it, and it's almost the same environment as it is the machines making MST bar. There is no smokestacks, there's no melting molten lava or steel. It is amazingly efficient that way for the carbon footprint that MST produces, so much less than anything that you could argue is steel. So yeah, great point. Marty, Marty, you're our final comment answerer here. And this is question 12. So this is the last of the bonus questions, but it's an important one. And the question is, how do we know what size MST bar and spacing of MST bar to use in my ICF build?
So in the in the ICF world, there are charts. Many different manufacturers have provided charts for each of their own products. I am in connection with the ICF-MA, where they are talking about a whole new set of charts in 2024, which they're working on right now, that are going to be amalgamated into one type of chart to minimize all the confusion going back and forth, whether it's an 8-inch spacing on webs or 10-inch spacing on webs. So with charts available with restrictions for certain builds up to certain size, certain height walls, it's literally, we're a 1-to-1 in 99% of the cases right now. And then once we get outside of those charts, by all means, get a hold of us. We'll get the engineers involved. Borna has a great team. They back us up on getting us information on specific job site situations, and then we carry on from there and do what has to be done. The biggest thing is going to be the ICF world is used to having these charts. We're mimicking them now to make sure that we're in line with the new charts, to make sure things are going to flow easy, so that most contractors carry on as they did in the rest, like in the days gone past. It's taken 20 years to get up to that point where these people feel comfortable using those charts, where the building committees or building departments use these charts, et cetera, et cetera, et cetera. It's all about communication to make sure your site-specific project is dealt with properly.
And I want to state one thing real quick. When Marty says get a hold of us, he means G2 Building Products.
Yeah, it's been a large collaboration with multiple people to try and develop these tables so that they are ultra easy to use for all these contractors. And it's been a lot of effort on Borna. Alicia's been involved, and Marty and other engineers in the process. So yeah, it's exciting to see all of this take off and the adoption of MST bar in ICF specifically, but then also in all the other applications where concrete is used. So I think that was a great wrap up, Marty, to kind of bring us to the end of this Q&A session. This has been fantastic. It's run a little long, perhaps, but all the information and the background and the content has been great. And so we really hope that you watching it is going to get value out of this and get confidence in what MST bar is, how fiberglass behaves versus steel, and particularly how it can be used in the ICF wall. I think, again, it's critical to remind everyone that's watching that today's conversation is specifically related to MST bar brand of grade 3 structural rebar. And that can't be emphasized enough, especially in all the drawings that Alicia has done. It's very specific to the properties and the product of MST. For more information, if you are interested in MST bar for your next ICF project, like Matt said, please reach out to G2 Building Products. G2 is the source for MST bar that serves the ICF industry with technical expertise, engineering expertise, and you can access MST bar across United States and Canada through G2 Building Products. Feel free to reach out to us online at g2buildingproducts.com or our toll-free number, which is 1-800-731-5098. Once again, everybody, thank you so much. Borna, Alicia, Marty, Matt, this has been fantastic. And for Tim for joining us as well. You clearly are the experts on these topics, and I think we went above and beyond on answering the questions with relevant and very detailed answers that are going to get anybody that's involved in ICF and rebar and concrete well on their way. So thank you so much for joining us. This has been great. I hope you've enjoyed yourself as well.
And I want to put one last point out there. Don't hesitate to ask more questions. That's what we're here for, as MST bar's usage is going to grow, 100% going to grow. So don't hesitate to ask those questions, and we can have multiples of these calls if we need to.
Yeah, that's great.
Thank you very much, everybody.
Always here to help. Thanks, Jeff.
All right. Thanks, Matt, for sharing your channel on this, and we'll see you next time.
Thank you all as well for participating. It's greatly appreciated.
All right.
Hey guys, take care.
Talk to you
Bye-bye.
later.
Bye.